Hello, guys. Are you okay?
So now, I just noticed that I on the what on the mic already. Sorry, I'm very sorry. Now let's start again. Let me start from the beginning again. Let me start from the beginning again. Now, what I was saying is that acid, okay, acid. Let's start again. Acid. Acid can be defined by three, according to three scientists. We have Arrhenius definition of the acid. We have what? We have Lowry definition of acid, and we have what? And we have Lewis definition of the acid. Now, so the three scientists can what? They actually what? Define acid in different ways. Now, the three scientists what? They define acid in what? In different what? Different ways. Now, the first one is Arrhenius. Second one is what? Is Lowry. We call it Bronsted Lowry. And the third one is what? Is Lewis. So do you get that? So now, according to what? According to Arrhenius, according to Arrhenius, the divine acid, according to Arrhenius, acid is a substance, is a substance that dissolve in water and produces hydrogen ion or hydrozonium ion as only positive ion. So now, according to this Arrhenius, so a divine acid as a substance that dissolves in water and produces hydrogen ion or hydrozonium ion at the what? At the only positive ion in what? In water. So that's according to Arrhenius. Now, I now say that according to a particular this scientist, according to this Arrhenius, we now have different type of the acid based on this definition of Arrhenius. We now have what's called the monobasic acid, dibasic acid, and the tribasic acid. Now, so according to this Arrhenius, I said we have what? We have different type of acid. Now, like for example, now we have what's called the monobasic acid. So according to this, we have what? We have monobasic acid, we have dibasic acid, and now we have what? We have tribasic. We have tribasic. But before we go there, before we go there, what is the basicity of the acid? What do you call basicity of the acid? Is what? Is the number of what? Of replaceable hydrogen ion in what? In acid. That is called basicity. JAMB usually ask that questions. That what do we call basicity? It can be defined as what? As the number of replaceable hydrogen ions in what? In one mole of the acid. So that's what's called the basicity. So now the basic can now be what? Can be divided either into what? To monobasic, dibasic, tribasic, and polybasic, depending on the what? On the compound given to you. But for jam we have monobasic, dibasic, and they can even what? Ask what? Tribasic acid. Now, so let's go. Let's go. Now, what are the monobasic acids? Now, monobasic acid include the following. Monobasic acid include the what? Include the following. Monobasic acid include the following. Now, example of monobasic acid, we have monobasic acid, they include the following. E.g., we have what? We have HCl is a monobasic acid. We have what? HNO3 is a monobasic acid. And we have what? CH3 COOH is what is a monobasic acid. Now, I will actually tell you the reason why this particular acid is a monobasic acid. I will tell you why. Why is ethanoic acid or acetic acid is what is monobasic. Now, let's start from the HCl. Now, HCl, you are going to have what? H plus Cl minus. You can see it is only this hydrogen ion that can be replaced by either metallic ions or by ammonium ion if they want to form salt. You get now? So for example now, if I remove hydrogen, from this HCl and I now put anything like a metal, I put like a metal like e.g. sodium. Now I have my Cl. You can see that I have produced what? Salt. That is now. So that is the number of hydrogen that can be replaced by metallic ion or in an acid is called the basicity. So that means the only hydrogen that can be placed in HCl is one. That's why we call it monobasic. So another one is HNO3. If I also dissociate this HNO3, I'm going to have what? H plus what? Plus NO3 minus. Now, if I remove this hydrogen now, and I include like sodium to it, so now I've already removed the hydrogen and now I have what? NO3. You can see how many hydrogen is replaceable in this particular acid is what? It's just one. So because of that reason, we call them monobasic acid. I get now, because anytime they dissolve in water, they donate only one hydrogen ions. That's why they are called what? They are called monobasic acid. I hope you get what I'm saying. Hope you can hear me clearly. So let me see your reactions, please. Very important, very important. And try to send the link to your friends so that they can join us, because we have not even started anything. We are still going a lot. What we are still going to pH calculation. We are still going to what? The gas law. We are still going to what? To standard electrode potential. Do you get what I'm saying now? So let me just see any questions. Any questions? Okay. Okay. Do you have any questions? Okay. All right. Let's start. All right. So if you don't have any question, now let's start our class. Let's start. Now let's clean it. Let's clean it and let's start the class. Okay. What of this guy now? This is CH3 COOH. This guy can be called ethanoic acid, or you call it acetic acid. Acetic acid. You can call it what? Ethanoic acid or acetic acid. Either what? Ethanoic acid or acetic acid. You can call it either ethanoic acid or acetic acid. I hope we are there. Now, how do you know that okay, this particular acid is what? Is a monobasic and not dibasic? But if you look at the number of hydrogen in this acid, it's how many? 3, 1, making 4. So why can't we call it tetrabasic? Or why can't we call it polybasic? And why is it monobasic? Very, very simple. Jam is not hard. Jam is not what? It's not hard at all. Now, okay, let's go. Let me clean it and write it again. Let me clean it and write it again. Now, I have what? I have CH3 here. I've been now CH3 COOH. Now, class, if you break this particular guy, if you break it down, this one I'm going to get CH3 COO minus plus H plus. This is the hydrogen ion that is replaced by what? By metal. You don't get what I'm saying. You don't get what I'm saying. H plus is the only, this one, the last hydrogen is the only one that is replaced by metal. Hope you're getting that. That's the only one that's replaced by metal. if they want to form salts. Do you get it now? Don't forget that in organic chemistry, there is what is called esterification reaction. What do I call it? Esterification reaction. A reaction whereby alkanol react with alkanoic acid in the presence of sulfuric acid as the catalyst to give us ester and water. Do you get it now? To give us, what? Ester and water. But here we are not here. We are not there. We are still going to talk about all those aspects, but not today. Now, so if you break this particular acid down, so this is what we are going to have. And this is the only hydrogen ions. These are the negative parts. It's like I have HNO3. I'm now breaking it down. I'll be having H plus NO3 minus. Like this one, NO3 minus is like CH3COO minus. The negative part of that particular acid is what? This one represent the negative part. This one represent the what? The positive part. This one represent the what? The negative part of this acid. Why this one represent what? The positive part of the acid. Now, is it only this hydrogen that is replaced by metal? Now, for example, now if I now put if I put what? A metal like a sodium in it now. If I put a metal like a sodium in it, I'll be having what? CH3, COO. You can see now how many hydrogen is replaceable? One. If I remove that hydrogen and I put sodium, what's the name of this compound? You now be calling it, instead of calling it ethanoic acid, you now be calling it sodium ethanoate. Sodium ethanoate. Sodium ethanoate. Sodium ethanoate. You can see now it's a salt. Sodium ethanoate is a what? Is a salt. Why? I've already removed hydrogen and now replace it with sodium. How many sodium did I replace in that acid? Just one. That's why it's a monobasic acid. I hope you are getting what I'm saying. So acid that I give you HNO3, HCl, and CH3COH. If your UTME asks you which of the following is a monobasic acid, it now give you H2O4, H2CO3, CH3COH, and what? And like ATPO3. What the answer is what? Is CH3COOH. Now, normal, there are 4 hydrogen, but it's only one hydrogen that is replaceable in that particular acid. That's why it's always a monobasic acid. I hope you are getting what I'm saying. Hope you are following me. Hope you are jotting down. We have not started anything. We haven't started anything. We still have what? Many things to learn. Hope you are jotting. If you are jotting, just click on what? On the like button. Let me see, maybe you are following me. Thank you. Let me check. All right. Now let's go. Let's go. This is what? That's according to what? To iron. So now dibasic acid. Dibasic acid. Dibasic acid. It means that they have what? When they dissolve in water, it means that they do what? They dissolve 2 hydrogen ions. They do what? They dissolve what? They dissolve They dissolve in water, and they contributed 2 hydrogen ions in water. Or let me say what? It's only 2 hydrogen ions that can be what? That can be replaceable. Their compound. Now, no, the first one is only one. It's only one hydrogen that can be replaceable. But this time around, it's only 2 hydrogen that can be replaceable. Now, example of dibasic acid is what? Is H2SO4, is always a dibasic acid. We have H2CO3, is always a dibasic acid. Hope you are getting that, is always a dibasic acid. Now, if I break down this particular acid, I'm going to have what? H plus SO4 2 minus Abi. So just put 2 here. You can see how many hydrogen does it donated when it dissolve in water. It donated just what? Just 2 hydrogen. ions. So the same thing applicable to this one too. Now, if I break down this particular acid, I'm going to have what? 2H plus plus CO3 2 minus, abi? So it means that what? This one too also what? Also donated how many? It donated how many? 2 hydrogen. So when dissolved in water, it donated 2 hydrogen. That's why we call it diabetic acid. Now note that if I give you A3PO3, please note that A3PO3 is a diabetic acid. Is a diabetic acid. Note it down. It's a diabetic acid. Why A3PO4 is tribasic. Note it down because jam can ask. So now that means what I've been saying since morning is what is the examples of monobasic, dibasic, and tribasic. So monobasic, they include what? They include, e.g., we have HCl, HNO3, and CH3COOH. And I explain why this one is a monobasic. Now, dibasic, we have H2SO4 is a good example. We have H2CO3 and we have A3PO4. Please don't say because of we have three what we have three hydrogen here, so that it makes this one to be what it makes it to be what uh to be tribasic. No, A3PO3 is a dibasic acid. Please note it down. It's a dibasic acid. But tribasic acid is now tribasic acid, e.g., we have arsenic acid. Arsenic acid is a tribasic acid, and we have A3PO4. We call it phosphoric acid. We call it phosphoric acid. So they are good example of tribasic acid. Now, how do we write arsenic acid? It's written as AS3 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 sorry, it's AS3 ASO4. So this is arsenic acid. So this is what A3 AS2 and AS2O4. So is what is tribasic acid. So why phosphoric acid is also a tribasic acid. Dibasic acid, they include what? A2CO3, A3PO3, HSO4. So monobasic ACl, HNO3, and CH3COH. That's according to the Arrhenius. Now let's move to the what? Let's move um to the Lorry Lorry definition of acid. Lorry definition of acid. Now, this one define acid. Acid is proton donor. Acid is a proton donor. So the proton donor. So if they ask you, which of the following scientists define acid as a proton donor? So is what Lorry, Buster Lorry define acid as a proton donor. So he said that okay, this proton that we are talking about is actually simply what? Hydrogen. Do you get it now? So hydrogen is a proton we are talking about here. For example, now I give you what? E.g. For example, now I give HCl. HCl now. HCl reacts with ammonia, right? To form ANH4 plus and Cn minus. Now look at it very well. Now this is this one will later form what? ANH4Cl. they form ammonium chloride. But before I combine it together, I know the ionic compound. So before I combine it together, now if you look at this guy very well, now this one it means H plus. If you break it down, you are going to have H plus. Now if you break it down, you also have Cl minus. This one too, we have NH3, just NH3. Now, do not forget that this one divine acid as a proton donor. Now, the proton that we mean here is hydrogen. So it means that this particular acid, it has donated this hydrogen to this compound, forming what? Forming NH4. Now, leaving behind this Cl. So the Cl will now come to the back. You can see now. So if they ask you, which of the following scientists define acid as a proton donor is what is a lorry, and the proton we mean here is what is hydrogen. Is what is hydrogen. But here there is one question that they usually ask. Now there's what's called conjugate acid. Conjugate acid and base. What do we call conjugate acid and base? I hope you are following me. Now, what do we call conjugate acid and base? Very, very simple. Now, you see, one thing you have to know is that acid, acid and its conjugate base, acid and its conjugate base differs by what? By one proton. And the proton I mean here is what is hydrogen. The what? The acid and its conjugate base differ by what? By one hydrogen atom or one proton. Also the same thing, base and its conjugate acid also what? Also differ by what? By one proton or by what? By one hydrogen. I hope you are following me. Now, acid and its conjugate base differ by one proton. Also, base and its conjugate acid differ by what? By one proton or one hydrogen atom. So this is exactly what we are talking about. Now, so don't forget that Lloyd define what acid as a proton donor. And the proton we are talking about is what is hydrogen here. Is what is hydrogen here. Hope you are following me. So let me check the number of people that would have joined the live video. Now, all right, let's go. Let's go. Acid is a proton donor, and what the proton we are talking about is hydrogen. Very good. Now, also, what's conjugate acid and conjugate base? I said acid and its conjugate base differ by what? By one hydrogen atom or one proton. Also, base and its conjugate acid also differ by what? By one proton or hydrogen. Now, for example, now they can give you question here. They can give you question and they now ask you that which of the following is conjugate acid. Now, assuming that they give us a particular question. Okay, they give us HCl plus NH3. Now give NH4 plus Cl minus. Now, in the above equation, the conjugate acid is A HCl, B NH3, C NH4 plus D Cl minus. Now let's attempt these questions. In the above equation, the conjugate acid is what? Now let's assume that this is your UTME questions 2026 UTME questions. So let's assume that that is what is your question. That's what you see. Now HCl plus NH3 to give NH4 plus Cl minus. So in the above equation, the conjugate acid is what? Let's check it. What is the conjugate acid? Anybody? Which one is the conjugate acid? Where's your answer? So the conjugate acid is what? Anybody? Okay. Now the answer is what? Don't forget that this, right? This is the acid. This is what? This is the base. Don't forget. Acid is what? This is base. Hope you are following me. This is the acid. This is the base. Now, and don't forget that acid and its conjugate base differ by hydrogen. Abi, it means that if this one is acid and this one is base, now if I remove one hydrogen here, I'm going to have Cl minus. Abi, definitely acid conjugate base. Acid conjugate base, because I said acid and its conjugate base differ by what? By hydrogen. And since if I remove hydrogen from acid, I'm going to have Cl minus. So HCl is an acid, Cl minus is a conjugate base. Now also, base and its conjugate acid. Here, this is conjugate acid. This NH4 is a conjugate acid. If base is NH3, abi now, and I add one hydrogen, I'm going to have NH4 plus, right? So if you remove one hydrogen from NH4 plus, you are going to have NH3. Definitely, base and its conjugate acid also do what? Differ by what? By one proton or one hydrogen. So this is where we are going to stop for now. Then I will give you break. Just 10-minute break and we come back again. Thank you.